Welcome, everyone. In this session, we have Elizabeth Beebe, data scientist at Gusto, presenting formal metrics or how I learned to stop worrying and love the YAML spec. Just a quick note to please post your questions in the Q&A box instead of chat. Elizabeth, a reminder to set your timer. Off to you.
Thank you so much. Hello, everybody, and welcome to Formal Metrics, or How I Learned to Stop Worrying and Love the YAML Spec. Just a quick introduction of myself to all of you. Hello, I'm Elizabeth. I'm a data scientist working in tech. I've done a lot of things while I've been doing all of this. I've been in tech for about 11 years now, across a lot of companies. I've done everything from dashboarding and reporting to analysis, experimentation, machine learning models, algorithms, more on the data engineering side with building out event logging frameworks and ETL systems, government filings. Basically, I feel like I am a Jill of all trades for all of this, and hopefully it gives me a little bit of experience to talk about what I'm going to talk about today, which, speaking of, a quick little overview of all of that. So this is kind of the high level of what we're going to go over today. First, I'm going to talk a little bit about how we build things today as data scientists. Then I'm going to talk a little bit about formal metrics. We'll go through a framework for formal metrics. We'll see how we can put those pieces of that framework together, and then we'll see how we can use those pieces to solve some problems using formal metrics. So to start with, we really need to talk about how we build things today as data scientists and why it's a giant pain in the keister sometimes. So the big thing really is this common anti-pattern that we get into a lot. Write some SQL and run it in a tool. And this happens over and over and over again. We write SQL in Tableau or Superset or Mode or Redash or whatever our dashboarding tool might be, and we build a dashboard, writing SQL, one query for one dashboard component, like a chart. We write some SQL in Python or Jupyter in our notebooks for analysis. We write some SQL again in those same things to look at the results of experiments. We write some SQL in a query tool just to get this one quick one-off piece of data. We write some SQL for an ETL job to build a data table in a database. And over and over and over, this pattern that we find ourselves in is, oh, I've got to do this thing. I'm just going to write a quick query. Because we do it so often that we internalize these things pretty well. And it's not a bad way to do it. There's nothing wrong with writing SQL. But what is happening is that we're doing it too much, and it's winding up creating problems for us. So what are some of these problems? One, we're writing the same code over and over and over and over and over again. And while we might be really familiar with it, we might understand the tables really well, we might understand everything really, really well, we're still writing dozens to hundreds, maybe even thousands of lines of SQL over and over and over again. And no matter how well we know the data sets, sometimes we're going to forget to add an AND clause. Sometimes we're going to forget to do a join. Sometimes we're humans, we're not perfect. Second problem, there's often conflicting definitions and conflicting sources of truth. I'm sure we've all seen in our careers, one dashboard says one thing for a metric, another dashboard says another thing for a metric. There's often messy or missing documentation because we're doing everything in a very one-off fashion. It's also difficult or impossible for non-experts to do it themselves because you have to know how to write SQL, which means you need to know all the data, you need to know the tables, you need to know the nuance and the little bits that go with it. And self-service exploration and discovery gets really hard for the same reasons. Everything's fragmented off into its own little world. Now, this isn't meant to be every single problem that exists. And for some ways that we approach this, these things don't really exist. But quite often, these are what we find ourselves thinking about or encountering. So formal metrics are a solution to these problems. The idea really boils down to this. We want to define things once. We want to use them everywhere. So let's talk about formal metrics. And this part's going to be surprisingly brief. Formal metrics are a way of specifying your data and how you transform it to define a useful metric. It's kind of like the T in ETL. If you're not familiar, that's extract, transform, load. It's kind of the process of getting your data from the nitty-gritty primordial state to something that's nice for humans. And interestingly enough, a lot of tools lately have started shifting that from being extract, transform, and then load to be extract, load, and then transform, just kind of how we're indirectly approaching it here. The other thing is that formal metrics usually aren't written as executable code. They're generally not Python, they're generally not R. They're more ways of describing how other things can construct code that can be run to generate the metrics data. So rather than writing some Python or some R or some SQL specifically, we're going to be defining ways that we can generate all of this SQL. So on that note, why don't we take a look at one version of a formal metrics framework and see what it can do? And when we're done, we're going to see how we can actually use that to use it for everything from dashboarding, analysis, ad hoc reporting, experimentation, and a whole lot of other use cases using standardized building blocks that have their documentation included with them in a form that's surprisingly human readable and actually fairly accessible for non-technical folks and easy to use. And yeah, we really can do all of that. So as we get into this, a few quick assumptions as we're building this out. One, we're going to write our definitions in something called YAML, which if you're not familiar, is kind of like JSON. If you're not familiar with either of those, the short version is it's a way of just specifying some data in a file that looks fairly human readable. Two, we're going to assume that our data lives in SQL because frankly, most of the time we find ourselves working with databases and it's a pretty common layer to work with. And third, we're going to assume that writing some Python or some R that can read YAML and run SQL scripts isn't something that's too difficult or outside of the realm of feasibility for us. So with that, let's get into it. So most of us have written one version or another of this query countless times. What's the average value of something? And I want to see it split across a couple of different things. And if you think about this for a moment, our query can really be generalized. We break out that we aren't having some specific column, but we've got a date key. We break out that we don't have some particular column that we're splitting this by. We have dimensions. There's some arbitrary aggregation function we're using. There's some arbitrary source or table that we're looking at to get all this data. So if we look at this, we see that there are really 4 parts to this query. We need to know what our time is, we need to know our dimensions, we need to know our aggregation, and we need to know our source. So if we take that, we can drop it into a file and say, okay, what are these things? And this is a very rough draft, just kind of starting to think about this. So don't worry too much about kind of weirdness or edge cases yet. But this is a good starting spot for us. So if we look at this and kind of think about that query we just wrote, that query is daily login authorization time by site location. And we have a description now for this and a name. So our metric already has gone from just being a SQL file to being something that really describes itself much more richly. We also have a data source that we're going to use and an aggregation function and a dimension. So at this point, all we've really done is changed from writing SQL to writing YAML. There's not a whole lot of value here. But I know most of you don't know me, but if you do, something I love doing is taking things far beyond reasonable levels of abstraction. And if we abstract this a little bit further, well, why point at a table when we can point at the definition of a table? Why point at an aggregation function when we can point at the definition of that function? Why point at a specific existing dimension when we can point at the definition of that dimension? So I'm going to start with that and run with it a little bit. And it's going to move a little bit quickly. I apologize for that, but there's just a lot to get through. This all works. I have built this. I have used this. So trust me when I say that this works. So we're going to start with a data source. And we're going to say that our data source needs a couple of different things. It needs a name, because you have to refer to a table by something. We need a description of that table so we know what the heck we can use it for. And we're going to give it an ID as well. And you'll see this name description ID paradigm repeat itself a lot here. The ID just being a way that we can nicely, from a code perspective, refer to it. We're also going to ask for something called an entity. We're going to ask for some SQL that defines our table. And we're going to ask to basically document and enumerate all the individual columns. And if we do that, we have something that looks like this. In the same way that we defined a metric, we can also define a source. And in doing that, we now have a fully documented table about What is the name of this? What's it used for? What are all the columns that we have here? What is the SQL that defines this? And so not only do we have a metric pointing to something that's also very nicely defined. Similarly, if we go back to our aggregator or aggregation function for SQL, and we kind of generalize that a little bit further, we get this same kind of notion of a name and a description and an ID. And we also add in some SQL there, because again, we're working as SQL as a base layer, and we give ourselves some input and output values because we need to know what columns we're going to give to this thing. And if we fill that out, we're going to make an aggregator called average value, and it's going to be the average value of an input column. It has an ID, so we can refer to it elsewhere. Glossing over stat test type for a moment. And it has some SQL that defines what the actual aggregation function in SQL is. So in this case, we're basically having this little SQL slug of average, standard deviation, and count. And I'll come back to the standard deviation and count part. The file also says, hey, if you want to use this aggregator, you need a column. And if you give me that, I'm going to give you a value and sigma and n. Moving on a little bit further for dimensions as well, similar thing. We have a name, we have a description, we have an ID. Kind of seen this at this point. It's the same idea. The only thing is that we add this notion of a dimension being valid from a period and to a period, which is just kind of a forced structure that's useful for joining things together. But you can see here, we have an entity as well, which is user ID, and we'll come back to that later of why that's important. So if we take all of this that we've just done and we kind of enhance our metric definition a little bit more, this is what we get. We get a metric called average time to auth by user type with a description of the average time to authorize a user login. It has an ID that we can reference in other places. It has a specific data source, which is our flogin data source that we defined a couple of slides ago. And it has a specific column from that source that we're going to use for all of our time references. Similarly, our aggregate is now fully defined. It's not just a function, but it's a function and its specific set of what arguments we're going to pass to that function. Similarly, we are calling out which dimension we're going to use and which dimension definition we're going to use and which dimensions from that definition we want to split things by. And then because we don't want to get too complicated and because frankly, it's just really easy to work this way, we have a filter that just says, drop some SQL in there. We're going to put a really sanity checking filter of the time to authorize has to be between 0 and 60,000 milliseconds, which basically means it has to happen within a minute. And we only care if it's a user who's an admin or a regular user. So with this, we have a metric. That's been a whole lot, I realize. So let's take a breath, exhale. There's a lot of structure that I just went over there. And what we're going to see here is how to put that together. So for each of our four parts for this, we have metrics, which are the definitions. We have sources, which are kind of like our from statement or our table definitions in SQL. We have aggregators, which are kind of like the select portion of our SQL. And we have dimensions, which are sort of like our join statement in SQL. And if we take this metric spec and we actually generate some SQL with it, we can see that our source maps to a subquery in our generated metric SQL, where we can basically stick that source's definition into that metric query. Similarly, for our login date time, we can stick that in. We can stick in our aggregation function programmatically because we've standardized and thought about how this is going to fit in there. We can fit in similarly as well our dimensions programmatically because we've created a nice way to join all these different Lego blocks together. Same thing for our filter, and all of this query gets filled in really, really nicely because we defined these things and how they interrelate to each other really, really well, all through this kind of metrics lens. So this is interesting, but what can we actually do with all of this? So let's actually use it. And let's actually think about how we can use this to solve our problems. Because right now, all we've got is, well, more SQL. And that's what we started with. So if we're doing dashboarding, for instance, one of the things you can do is you can just generate all that SQL for all the metrics you have, Do you solve the same problem of you're taking SQL and you're dropping it into a query? Sure. But now that SQL is all located in one place, and you can say, this is our canonical place for everything. If you would like to use a metric, you can just come here, grab it, drop into whatever it might be. Lightweight, it works. You can get a little more advanced when you start thinking about some of the dashboarding tools that exist and how they allow you to use snippets or templates or macros and do things like, for instance, instead of copying and pasting the entire query, those tools allow you to define references for those things. So you could define an official, this is a average time to auth metric, and have that as a template or a macro that you could insert in. You can also create tables of metrics where you just decide on a standard structure and all metrics live in one table. So rather than querying every individual metric every single time in every single place, you just kind of pre-compute everything and point at the pre-computed metric. What about ad hoc analysis? Well, we have all these definitions and we've already been kind of implicitly writing some Python or some R in order to actually create all of that SQL out of all of those definitions. So why not take that a step further, and rather than giving us SQL as an giving us SQL as a final output, we actually use that to define some Python or some R that we could use to interact with metrics in a more native way and without having to think about managing those queries. If we want to do ad hoc exploration or self-service data, we can actually change the definitions of things. Like, what happens if we take a metric definition and we change what dimension we use? We can just generate new SQL for that. And if you step back and you think for a moment about our definitions for dimensions and sources, we know what the entity is that a source refers to. What is the thing that this data set's about? We have the same thing for dimensions as well. And since our dimensions know what they're about and our data sources know what they're about, we know what data sources are compatible with what dimensions. And we can go and we can say, what's everything that we can join up to any given data source, rather than rewriting and rewriting and rewriting and rewriting or rewriting. And then you can layer that on top of what we were talking about before, where either you're generating some SQL or you're just referencing that SQL, or you're using templates or macros, or you can do some pretty lightweight stuff with either Shiny in R or Streamlit in Python in order to create really lightweight, simple, quick to put together interactive tools for folks to use using this. So experimentation, well, because in our aggregator, we happen to define mu, sigma, and n, we can actually do t-tests. And since experiment enrollments are just a different type of dimension, really, it's easy for us to define this SQL. And since everything that comes out from our SQL for metrics is in a fairly standard form, it's easy for us to take that output and then have it ingested by something else that's going to calculate statistical tests, visualizations, all these other sorts of things. Documentation, same thing. Because rather than hard coding everything, we've given references to everything. It's not too hard for us to take all of what we've written and change it from being a spec file into being something that's a little more human readable. Not just human readable, but human navigable. For instance, in this kind of toy example here, we've transformed this metric definition into a more readable page. Our data source is listed there, as is our aggregator. There's no reason we can't link to the definition of that data source and its own documentation. Similarly, there's no reason we couldn't say, look at a data source and then derive from that every single metric that uses it, because we know that. We know every metric. We know what data source every metric uses. So we can create these really powerful, useful references for documentation as well. ETL, similar thing. Really common pattern for ETL is having, I have a table, I'm going to write an ETL file or an ETL job. I have another table, another file, another ETL job. Same thing, more jobs, more jobs, more jobs, more jobs. What if instead of defining ETL jobs for each table or each metric, we defined pipelines, and we then iterate through all of our metrics or through all of our sources? And now, rather than building things over and over and over, we just have to maintain one little thing. Machine learning, why not add a fifth component called a feature? So I know this has been really quick. Sorry. Um, but in short, we write the same SQL a lot, and it's not a great pattern for us to get into. It's very manual, it creates a lot of issues, but formalizing our metrics can help us exploit patterns in all of this. And with a good formal metrics framework, we can solve these problems across a lot of our use cases. We can solve a few other problems we may not have been expecting to. We can extend and adapt our definitions to solve problems we hadn't even considered. So I will just leave a parting thought then. Just think about what are the patterns in what we do as data scientists, and how can we make use of them? Thank you.
This was great. Thank you so much, Elizabeth. Really great explanation of all this. We do have a couple questions.
Yeah.
I'll start with this one. Okay, well, first is we'd like a link to the slides. If that can be provided, then we will put that with the recording when we put it in YouTube and on the blog post in Data Circles. Yep. But another question is, do you have any open source examples of some of these formal metrics that we could poke around with? I love to see a more thorough implementation.
Yes, there's actually, DBT is a company that does a lot of structuring of this from a data first perspective, but they just released their, into beta, their metrics framework, which in a similar way to this unifies everything. They've come at it from a data first and then metrics downstream from that perspective. I've tended to come at this from a metrics first and then data downstream, but DBT is definitely very similar ideas.
Cool. And then she follows up with, I haven't used DBT, but this seems to cover a similar space. Yeah. Do you know what the differences existing between this approach and DBT? So yeah, I think that was kind of covered there.
Cool. Yeah, I mean, it's interesting because we're looking at adapting DBT ourselves just because this has been built out by other companies in one form or another. If you go look up Airbnb's, I think it's Minerva system, is a extremely technical, high-end, like you've got dozens of engineers to throw at this problem version of this. But for DBT, yeah, I think the big difference that I've seen from the little bit I've been able to use of it is DBT comes at this from a data first perspective of how do we define and structure our data, and then metrics are a byproduct of that. And I've come at this from more of a perspective of what do we want in our metrics, and then what does that mean for how we structure our data?
Cool. Well, I think that's all the questions we have. Maybe we do have 2 more minutes. So if you guys have another questions, feel free to put it in the Q&A. I can check the chat too in case someone else said anything in there. Lots of people want to dig into what you did, so that's good. They're eager to dig in.
Yeah, slide deck will be, I believe you said, up with the presentation when it's posted later. Yeah.
Absolutely. All right, great. Well, thank you for the great presentation, Elizabeth. This concludes our session. If you have additional questions for our speaker, you may send a direct message to her in Excel events or send her an email at elizabeth.beebe@gusto.com. And I also put that in the chat. We look forward to seeing you in the following sessions and the expo booths. Thank you to everyone for being here today. Have a great day. All right, we have 1 more minute technically, and Janet just asked another question. Interesting. Can you talk about the advantages and disadvantages of data first versus metrics first?
Yeah, I mean, the short version of it, and again, this is very limited. I'm not super expert on this. To my mind, what it comes down to is what is the framework you're trying to fit everything downstream of it into? Everything. So from a data first framework perspective, the problem is how do we structure and organize and manage all of our data? And then we layer on top of that, oh, well, how can we build some metrics out of this? And there are some things that may work better and may not work as well when you do that way. I'm not super familiar with DBT's metrics API. It's still in beta, so it's still changing. They may solve some of these issues, but things just like co-locating documentation for metrics. Their approach also, I think, tends to take an approach to metrics of a metric is just kind of a amalgamated data source, which isn't a bad idea either. I've kind of toyed with it a little bit myself as well. But what it means is that your metrics have to fit into how you've structured your data, versus a metrics first perspective says, what is a metric? What does it look like? And what do we want to use it for? And then how do we have to structure our data to accomplish that? And there's some generalizations that allows for your data that something that comes at this from the data first perspective doesn't necessarily allow you to do, or maybe more difficult to do. Basically trading complexity in one area for complexity in another area.
Interesting. Well, cool. Awesome session. I really enjoyed this. I was very proud of myself that I could follow along because this is what we use at our company for our tools. So that was cool.
Yeah.
But yeah, very, very great talk. Good job.
Yeah. Thank you.
Cool.